Now let's work on some interesting pulley problems. We'll just start with this one here. We're looking for the minimum force required to lift each of the 100 kilogram boxes. So the box is 100 kilogram, and when we talk about minimum force required to lift the box, that means that we're not pulling any harder than necessary. We're not pulling any harder to make the box accelerate. So when you exert this minimum force, the acceleration is 0. The box is just going up at a constant velocity. So if we look at the box, the acceleration is 0. And we draw the force diagram, we would have mg, that is 1,000 newtons. The box is only touching the string, so you got the tension. Acceleration being 0 means the tension has to equal to 1,000 newtons. Now, this is the same string, so the tension is the same 1,000 newtons throughout. This means if you're grabbing onto the string is pulling on you with 1,000 newtons. That means you must be pulling back on the string with the same 1,000 newtons. So in this case, the answer is 1,000 newtons. That's how hard you have to pull, because you got one string supporting the box. So the tension has to be 1,000. Let's look at the next one. For this one here, how hard do you think you have to pull to lift the box? What's the minimum force? So in this case, again, you got mg, that is 1,000 newtons. Now that means the force in here, this support, must be 1,000 newtons, the tension in here. But that doesn't give you the tension in this string. So it can be convenient for us to look at the pulley and this box together as one system. Put them in a black box. They are connected, fixed together anyway, so they're going to move together up as you pull the string. So if we treat this as one object and the pulley is massless, so the mg will still be the same 1,000 newtons, and you have two strings touching this object, which means you got a tension pulling and a tension pulling. So you got tension, tension, two tensions. And since they are the same string, it is the same tension, which means basically you have two t's going up. So it's mg and 2t. That means if the acceleration is 0, 2t equals to 1,000, the tension will be 500 newtons. So you must be pulling with 500 newtons. It makes sense because this 1,000 newtons is supported by two strings. Since they are the same strings, the tension is the same, so it's 500 each side. Let's see the next one. Again, a 100 kilogram box. What do you think the minimum force required to lift the box is? For this one, down here you got 1,000 newtons, and those two is the same string, so it's 500 on each side. Now this 500 pulls down on this pulley. The pulley has no mass, so there's no mg, so just 500 newtons pulling down, and same string, two of those touching the same pulley twice. So 2t is going up. That means that it must be 250 on each side. They are the same strings, so it's the same tension. These two strings are not the same, so they don't have the same tension. So your pulling force in this case is 250. We can also look at this part. you got 1,000 newtons to lift. And if you look above here, there's one string 500 newtons, one string 250, and this person pulling with 250. See, 500 plus 250 plus 250, that's 1,000. So it works. How about this one? What do you think the minimum force required is? So for this one, we can look at the box which is attached to this pulley, which is attached to that pulley. So when you pull on the string, all of these, they go up together, which means it can be convenient for us to put all this in one black box. Treat all this as one object. Since the pulley has no mass, so we just ignore the mass of the pulley. So down here, you got 1,000 newtons pulling, and this whole thing is touching the same string 1, 2, 3, 4, 5 times. So there are 5 T's going up, because every time you touch a taut string, you get tension pulling on the object. So 5 T's going up, so 5 T's going up, that means each tension is 200 newtons. So you only have to pull with 200 newtons. What if we need to find the force from this support right there? The force from this support, let's see. For that one, we can look at these two pulleys because they are attached together. The pulleys have no mass, so no mg, but they are touching the support on the top, and the same string 1, 2, 3, 4 times. So there's 4T. So you have 4T going down, and this support force going up. That means how much force is up there? It's 4 times the tension because there's no acceleration. So the net force is 0. F equals to 4T. Each tension is 200. So this force right there must be 800 newtons. And then if you look at this whole system, including the box, you got weight 1,000 newtons. The support here provides 800 newtons. The person pulling here provides 200. See, the total is 1,000. What about this one? What's the minimum force? Okay, so here, this is 1,000 newtons, and it is being supported by 2 strings. So each side must be 500 because it's the same string, so the same tension. 2 strings split. So 500, 500. And that's the same string, so it's the same tension. However hard you pull on the string is going to pull back with its tension since those two forces are equal and opposite, action force and the reaction force. So they must be 500, 500, same as the tension because it's the same string. So you'll be pulling with 500 newtons. Okay. Now, does it matter whether you're pulling horizontally or at different angles? Would the force required be different? See, down here we found the tension has to be 500. And that's the same string. It doesn't matter at what angle you pull it out. The tension is still 500 newtons. So it doesn't matter in which direction you pull. The pulling force will still have to be 500 newtons. Same for this one here. The pulling force has to be 1,000 newtons. It won't matter whether you pull it horizontally or at angle. Any of these will be 1,000 newtons. Now the last one. We got a bucket and the person's in the bucket. The bucket is connected to the rope. The rope goes over the pulley and the person is pulling on the rope on the other side, pulling the rope down to lift herself up. If the person plus the bucket together is 100 kilograms, how hard does she have to pull to lift herself? What's the minimum force required? Now in this case, it's convenient to look at the person and the bucket together as one system. So if you put them in a black box, the gravitational force pulling on them is 1,000 newtons. And they are touching the same rope twice. This part hanging, the rope is slack, so there is no tension pulling here. There's only the tension pulling up here and there. So this rope's tension pulls on them twice. So you got 2 T's going up. Same rope, same tension. So what should 1 T equal to? 500 newtons. So she has to pull with 500 newtons force. So she can go up at a constant velocity. No acceleration. Of course, if she wants to accelerate, she will have to pull harder than that. Let me show you some pulley systems I have set up here. Let's start with this one. I have 1 kilogram hanging there, which means 10 newtons. And I'm pulling down this way here to lift the 10 newtons. How hard do you think I have to pull? What's the minimum force I have to use to lift this 1 kilogram? So let's see. It's the weight, about 10 newtons. Because this is 10 newtons. It's being supported by one single string. So the tension in the string must be 10 newtons if we don't desire any acceleration. So no acceleration, downward 10 newtons equals to the upward tension. So tension is 10 newtons. This is the same string, so the tension is the same throughout, so it's 10 newtons. And the angle does not matter because the tension has to be 10 newtons. And this pulley allows us to change the direction. Okay, now let's look at the next one. This one here, we hand the weight down here, and it's lifted with this string. How hard do you think I have to pull in order to lift the 1 kilogram? Now let's see. So the scale reads about 5 newtons, right? Because 10 newtons in this case is supported by 2 strings. So each string has 5 newtons. Each string supports 5 newtons. It's the same string, same tension. So 5 on each side. And the scale supports 1 tension, 5 newtons. That's why it reads 5 newtons. This next one is more complicated. So I'm putting this dark color in the back so you can see the strings better. I'm going to lift with this string. How hard do you think I have to pull to lift the 1 kilogram? What is the minimum force I have to pull to lift it? Okay, let's see. In this case, there are 1, 2, 3, 4, 5, 6, 7 strings. There are 7 strings supporting the 1 kilograms. So 10 newtons divided by 7, you'll get about 1.43. So let's see. Is it about 1.43? It's a little more. That is because, why do you think it should be a little more than 1.43? Because the pulley system has mass. So it'll be 10 newtons plus the pulley's weight divided by 7. That's why it's slightly more. And like this.